right, so an arithmetic sequence is really just a linear sequence. So when we talk about linear, we kind of need to think back to the fact that we have y equals mx plus b. We know we have a slope, which is our repeating value, and we have the y-intercept, which is the initial value. So an arithmetic sequence is the same concept, and we need to make sure that we are looking for what we call the common difference. So the common difference is just like you would when you were in third grade and you learn how to determine what the change was between each piece. So when we're going from 10 to 3, we're adding 3 each time. Or excuse me, 10 to 13, 13 to 16, 16 to 19. So my common difference in this particular problem is plus 3. That is actually the slope. Okay, so when you're thinking about a linear equation, that repeating value is your slope value. Now, we're going to learn about two formulas in reference to an arithmetic sequence, and we need to make sure we understand what it means when we're talking about a term. So a term is the actual sequence number. So this is term 1, so n represents term. This is term 2. This is term 3. This is term 4. We could keep going, but n represents the term number. So the two formulas that we're going to talk about are recursive and explicit. So recursive is the formula that can take the most time because you have to know your previous term in order to find your next term. So if you want to find term 100, you would have to do it 99 times in order to get to the 100 term value. So first thing we need to understand is the notation. So when we're looking at this, we have A1. A1 stands for the value of the first term, okay? So whatever that first term is that value. You have to know the first term in order to complete the process. All right, then we have A sub n. So A sub n is just a notation. That means the value of whatever term you're looking for. So if I have A sub 100, I'm looking for the value of the 100 term. Now, this is the one that confuses students the most, which is A sub n minus 1. N minus 1 means if I'm looking for the 100 term, 100 minus 1 means the 99th term. So n minus 1 means the previous term, which is why this is a linear process because you have to know the previous in order to know the next. So if you find term 1, then you use term 1 to find term 2. If you know term 2, then you use term 2 to find term 3. And then plus the common difference, which is that value that it's changing by. Okay? So when I'm looking at this particular sequence at the top, I know that my initial term, so A sub 1, is going to be 10. Now we're going to write the actual recursive formula for any term. So A sub n is going to be the previous term, so that's always going to be the A sub n minus 1 plus the common difference, and the common difference is 3. So if I were to actually work backwards, this would tell me, if I start with my first term, that's going to be 10. Then my second term tells me to take my previous, all right, so it tells me to take my previous and add 3 to it. So previous and add 3. So that's going to be 13. And this should be second, not 3. All right, and then if I want to find my third term, we're going to add 3 to 13, which gives me 16. And I could keep going on and on with that process. So recursive, depending on which term you want to find, can be very lengthy in the process. Now, an explicit formula. The explicit formula tells me that I can find this explicit value. So if I want to find the 100th term, I don't have to go through 99 other ones in order to get to the 100th. I can explicitly find the 100th term, just that term. But in order to do that, I've got to write a formula for it. Now, there are multiple ways to do this, and you will learn all ways as you go through your math classes. However, I feel that if you can link this to your linear process that you learned previously, your y equals mx plus b, this is going to be much easier. So I do the Dino method, however you want to explain it or say it. So what does this mean? So the Dino method, it says, first you're going to tell me what the common difference is. So the DI stands for the common difference, okay? Then we're going to use the n. The n is my variable. And this last part requires you to understand what the initial value is. If you were talking about a linear function, then you're talking about the b, the y-intercept. And that is going to represent the initial value or term 0. Okay? So when I write this, I'm always going to write that n sub 1 because that means, or a sub n, because that's going to represent any term I'm trying to find. So what I do here is I have the common difference. Well, if I look at my original formula, my common difference was 3. So 3. The n is a reminder that that needs to be a variable there. Normally we would use x if it was linear, but since we're doing sequence, we use n. And then finally, we have this initial value. So we kind of got to work backwards here. So what do I mean by work backwards? So when I'm looking at my problem, I have, all right, so I have the first term. I need to go back and find the 0 term. So I got to do the opposite. So if I was adding 3 each time, if I'm going backwards, I'm going to subtract 3. So 10 minus 3 means my initial value is going to be plus 7. So that initial term is going to be plus 7. So let's say that I want to find the 100 term. So I want to find a sub 100. Well, all I have to do is plug in. If n represents 100, then all I have to do is plug in 100 for n. So 3 times 100 plus 7 is going to equal 307. So the 100 term has a value of 307. Okay? So let's look at another example. So if I give you the term, and I have 50, 44, 38, and 32. First thing I'm going to do is I'm going to look at this problem and I'm going to figure out the common difference. So I'm going down this time. So if I'm going down, it's going to need to be subtraction. So 50 to 44 is minus 6. 44 to 38 is also minus 6. So my common difference for this one is 6. Or excuse me, minus 6. So we're going to write the recursive formula first. All right, so my recursive formula requires 2 things. I need the initial term, so a sub 1 is going to be 50. And then I need to write what's going on from the previous. So remember, the previous term is represented by n minus 1. And we need to write our common difference, so minus 6. So if I want to find the second term, 50 minus 1 gives me 44. If I want to find the third term, it's 44 minus 6, which is 38. Again, recursive, if you want to find the 100th term, you'd have to do it 99 times so that you could find the 99th term in order to find the 100th term. All right, so with your explicit formula, again, there is an official formula for it, but I like using that Dino-Dino method, however you want to pronounce it. So in my term, I need my common difference. Okay, so my common difference is that what DI stands for. My common difference is negative 6. I am going to write my n variable. That's a reminder to bring it down. And then that last piece is going to be your initial value. So how do I find the initial value? Well, if this is my first term, and this is my second term, and this is my third term, and so forth, I need to go back to my 0th term, my initial amount. So if we're thinking about linear, it will be the y-intercept. So before, we were subtracting 6 each time. So if I'm going backwards, I'm going to add 6. So 50 plus 6 is going to give me 56 is my initial value. All right, so when I write this, I got to make sure I say the a sub n equals negative 6n plus 56. So let's say Obviously, if I wanted to find the fifth term, all I would do is subtract 6, but I can still use my formula for any term I want. So 5 means I'm going to take that 5 and plug it in for n. So negative 6 times 5 plus 56. All right, so we have negative 6 times 5. That's going to be negative 30. And then I have negative 30 plus 56. That's going to give me positive 26. And I can test that and say, okay, well, I found my fourth term. My fourth term was 32. So if I find my fifth term up here, the pattern was to subtract 6 each time. And I subtract 6 again. So right here, if I subtract 6, my next term would be 26, which is exactly what I got. So hopefully this helps. But between the two formulas, recursive, you have to know the initial, and you have to state the the first term, and then you have to always notate your previous, so a sub n minus 1 plus or minus the difference. For the explicit formula, again, I like using the Dino method, however you want to say it. DI stands for the common difference, so we had the common difference. N tells me to bring down my variable, and the initial value is what O stands for. So that means we're going to go back to term 0, and we're going to do the opposite of the